Welcome to MyProjectBazaar.com. Now we discuss about the product for an efficient VLSI architecture of a reconfigurable pulse shaping FIR interpolation filter for multistandard DUC. Now we see the abstract for the product. Requirement of various high data transfer rates and high channel capacity by different operating modes of a present day cell phones motivated the telecommunication industry to span the concept of software defined ratio. According to previous papers, STR refers to the single device that is capable of supporting all the person as well as emerging standards available under the wireless communication category. In a STR system, multiple standards can be realized in single chip by providing the programmable channel selector at the baseband levels. Different standards have different channel bandwidths, sampling rates, carrier to noise ratio, blocking and interference profiles. This makes the development of reconfigurable sample rate converter chip to be major challenge faced by the telecommunication industry of today. Several researchers have contributed towards designing a low power, low area, low complexity reconfigurable channel filter for a high data rate conversions in SDR systems. I have proposed a combination of symmetrical retimed direct form processing architecture and modified canonical significant digit technique based on the finite impulse response filter to improve the power consumption level. However, the reduction of power has been achieved by compromising with the speed operation that makes the design of unsuitable for the SDR system. This the proposed two-step optimization technique for designing a reconfigurable VLSI architecture of an interpolation of multi-standard digital up converter to reduce the power and area consumption. The proposed technique initially reduced the number of multiplication per input samples and addition per input samples in comparison with individual implementation of each standard filter who designing the root raised cosine finite impulse response filter for multi-standard DUC for 3 different standards. In the next step, a 2-bit binary common sub-expression based on BCS elimination algorithm has been proposed to design an efficient constant multiplier, which is the basic element of any filters. This process to modify the FIR filter architecture for based on digital up converter technique. Next we see the flow diagram for the product. First we apply the signal input data bits and the clocking sequence. This process mainly based on the architecture oriented FIR process. So we focus the architecture for digital inputs given and selected desired signal inputs, then to get the final filtered output signal. This process all mainly based on the binary based architecture oriented process. So we design the data generator architecture based on the input sample and clocking sequence. Then to apply the coefficient generator architecture. This generator architecture to produce the desired signal based on the digital up converter technique. This converter technique mainly focused by bandwidth based allocation for desired input signals. This desired signal mainly based on first code passing section and second code passing section, then the partial product generation. This partial product generation mainly focused by shift add architecture block. The first code and second code architecture process to select the what are the desired signal presented in the which band allocations, then to apply the coefficient generation architecture results, then the results to apply the channel selection logical blocks. These channel selection logical blocks mainly based on the mux oriented selection sequence for given the selected input signals, then to apply the mux selection and logical control. This mux selection logical control to identify the which output results to be selected by given multiple input channel selections. Then to apply the final accumulation unit. This accumulation unit to identify the 7 channels for channel selection output results, then to identify the overall information and to get the final output results for given input FIR filter input signals, then to identify the final output architecture. This architecture to perform the simulation and synthesis performance analysis. The simulation process to identify the informations for given binary and binary output result. The synthesis performance to identify the what are the area and power and circuit complexity optimization presented in our required FIR filter architecture using VLSI process. Then finally we see the output for the product. Our architecture was developed in Xilinx 14.2 version software, and this process was developed in VHDL language. This is our the overall architecture process. This is the required VHDL code process for overall filter architecture. Then to select the signal and to simulate the simulate behavior model. This model to simulate the overall architecture process. This process to create the iSIM project navigator. This navigator mainly used to simulate the overall process to apply the binary given inputs and decide inputs, then the selection logic, then to get the final output results for overall architecture. This is our the overall simulation input processing architecture result. This is our the clocking signals to control the overall architecture. This is our the input and decide signal outputs, then the selection logic, and to get the final RRC output results. This is our the overall architecture. Then to apply the clocking sequence for our architecture, then to apply the decide input signal for one by one. Then to run the time specified on the toolbar. This is our the given input signal and decide signal, then the overall architecture process. Our output process to apply the clocking sequence and to get the final filtered output results for overall architecture. This then to apply the full clock signals and to get the final output results for overall architecture. This is our this processing results for filtered output results for given input signal and the decide signal based RRC filter architecture. Then to run the then go to the simulation work window. This simulation window to select the simulate behavior model and to create the RTL diagrammatic presentation. This RTL diagram to represents the what are the logical blocks presented in overall architecture. Then to calculate the technological diagrammatic representation. This technological diagram to what are the buffers to be presented and the what are the lookup tables and buffer logic, how to connect the overall architecture process to identify the final output results. This is our the architecture performance analysis for FIR filter architecture process. Then to identify the processing process, then to create the what are the logical blocks presented in our overall architecture. This is our the architecture for overall processing results. Then to calculate the technological diagrammatic representation. This diagrammatic representation to be presented the more logical block presented, so the processing was this is the overall lookup table and input buffer functions for our LUT structures and buffer gate initialization for overall architecture. This is the overall structure. Then go to the design summary process. The design summary process to represent the what are the presented for overall architecture results and processing results for final output results. Then call to the architecture for overall RRC filter architecture.